Every computer does the same three things with information. It takes data in, it works on it, and it puts results back out, and somewhere along the way it has to remember things, both for a moment and forever. That is what the physical hardware is for. This unit is the physical machine itself, the devices that carry data in and out, and the very different technologies we use to store it. No software, just the tangible parts you can hold in your hand. Input devices capture data from the world and turn it into bits the processor can use. A keyboard turns key presses into characters, a scanner turns a page into an image, and a sensor turns temperature or motion into numbers. Each one is a doorway in. Output devices do the reverse, turning bits back into something we can see, hear, or feel. A monitor paints pixels, a printer lays down ink, a speaker pushes air into sound. Input brings the world in, output sends the results back out. Closest to the processor sits primary storage, and it splits in two. RAM holds the programs and data you are using right now. It is fast but volatile, meaning the moment the power goes, everything in it is gone. That is why unsaved work disappears in a crash. Its partner is ROM, read-only memory. ROM is non-volatile, so it keeps its contents with no power at all, and it holds the small fixed program that starts the computer up before anything else is loaded. Fast and temporary versus permanent and unchanging. To keep data permanently, we turn to secondary storage, and the oldest workhorse is magnetic. A hard drive spins a metal platter thousands of times a minute, while a tiny head flips the magnetism of each spot to write a 1 or a 0. Magnetic drives give you huge capacity for very little money, which is why data centers are still full of them. The catch is the moving parts. Spin a delicate mechanism at speed, and a single knock can wreck it. Cheap and roomy, but fragile. Optical storage, like a CD or DVD, takes a different route entirely. A laser burns microscopic pits into the surface, and the same laser later reads them back as light bounces or scatters. The disks are cheap and portable, but hold little and read slowly. Solid-state drives have no moving parts at all. They trap electric charge inside billions of tiny flash memory cells, so there is nothing to spin and nothing to break. That makes them fast, silent, and tough, though you pay more for every gigabyte than magnetic gives you. Finally, there is cloud storage, which is really just someone else's drives, kept in a data center and reached over the internet. You get access from anywhere and automatic backups, but you depend completely on a connection, and you trust your files to a third party. So there is no perfect storage, only trade-offs. Magnetic is cheap and roomy, optical is portable, solid state is fast and tough, cloud is reachable anywhere. The exam wants you to weigh speed, capacity, cost, and durability, then pick the right tool for the job. Every system is built around the same flow. Input devices like keyboards and sensors bring data in, the computer processes it, and output devices like monitors and printers send the results back out to us. Closest to the processor sits primary storage. Secondary storage keeps data permanently and comes in four flavors: magnetic drives, optical disks, solid-state flash, and cloud storage over the internet. There is no perfect storage, only trade-offs in speed, capacity, cost, and durability. The exam wants you to weigh speed, capacity, cost, and durability, then pick the right tool for the job. This unit is the tangible machine only. The inner workings of the processor itself come later.